Hi team, I'm Maddie. Welcome to Science Side Up. Today we're going to talk about gamma radiation, what it is, how it affects living tissue and the human body, and why Bruce Banner would have just died. So for those of you who don't obsessively go to every Marvel movie opening in the last 10 years, Bruce Banner is the Hulk. So the way the story goes is Dr. Bruce Banner is doing science in his science lab, and there's an accident and he gets exposed to massive amounts of gamma radiation, and now every time he gets angry, he becomes the Hulk, and we get great quotes like, "You don't want to make me angry. You don't want to see me when I'm angry." Is that the quote? I think it is. So Bruce Banner first showed up in the comics, and I think 1963, if I'm wrong on that. We're gonna blame my husband. He's way more into comics than I am. And I asked him, and that's what he said. I love early 60s, just early science fiction stuff for that, because you can just put the word atomic or nuclear or radiation in front of anything and do anything you want, right? You can get, giant green monsters, you can get giant ants, anything you want. It can do anything you want. And that's not how the science works in real life whatsoever. But what's actually kind of funny is that in modern sci-fi, we do this with the word quantum. So they did that in Ant-Man and the Wasp, right? So in Ant-Man and the Wasp, right, he's doing quantum research, and there's an accident in the lab, and now he can get really tiny because of quantum, which is not even a little bit how quantum mechanics works. Unfortunately, it's really not that cool. Like, quantum mechanics is cool, but it's not, like, accidentally turning you into Ant-Man cool. Okay, now I'm going to talk about science stuff. Cool. So if you have watched my video on the particle wave duality of light, then you know that a photon is just what we call light when we're talking about it in its particle form. And for now, when I'm going to talk about photons, I'm going to write the Greek letter gamma. Looks like that. And that's mostly from convention from nuclear science land. But if you're sort of guessing the end here, gamma radiation are just high energy photons. But we're going to talk more about that. So first, let's go through things photons have and things photons do not have. So photons have energy and momentum. I think I spelled momentum right. And then there's a couple things that photons very specifically do not have. So photons do not have they do not have mass, and they do not have charge. I think I might need to get a more stable easel. Okay, so photons do not have mass or charge. And of these two lists, there are two things that are really important for how gamma radiation is going to affect living tissue, so how it's going to affect you and me. And that's that they have energy and they do not have charge. So let's talk about that charge of why that's important for a second. So something with positive charge will repel something else with positive charge or attract something with negative charge. Conceptually, it works the same way as magnets do. The fact that photons do not have charge means that they're not going to attract or repel any other particles. So all they can do is give their energy to some other particle. And so now let's talk about why I'm writing this as a gamma through the magic of editing and the electromagnetic spectrum. So this, channeling Vanna White for a second, is a diagram of the electromagnetic spectrum. So like I said earlier, photons have energy. And But not all photons have the same amount of energy. So we can classify them. We can put them somewhere on this chart based off of how much energy they have. So very low energy electromagnetic radiation, low energy photons are radio waves, right? The same thing you get in your car. Then slightly higher energy, you get microwaves. Then you get the infrared range. Then we get visible light. And after visible light, you get ultraviolet, X-rays, and gamma rays. And so the highest energy are going to be gammas. And so that's why when we're talking about nuclear things, so radiation, damage, gamma radiation, we tend to write that gamma symbol because usually we're talking about very high energy photons. Usually when we're talking about radiation damage from photons, we're talking about gamma, the highest energy. However, ultraviolet, X-rays, and gamma rays, so this whole range here, those are all high enough energy that they can do damage to you. So we call this ionizing radiation. Yeah, so collectively those are called ionizing radiation. So ionizing radiation is another way of saying radiation which can cause biological damage. And this, hopefully this is a little intuitive, right? Because we know that ultraviolet light is what gives us a sunburn. So yeah, a sunburn is actually just a radiation burn, just the most mild version of that. So I don't recommend sunburns. Okay, so this is the EM spectrum, ionizing radiation, and now we're going to talk about why it's called ionizing radiation, and that actually gets us to the mechanism of how gamma radiation does damage and why Bruce Banner would have died. Here we have a photon that's coming in to interact with some atoms. Okay, now remember that photons do not have charge, but they do have energy. And so what's going to happen is if this photon happens to basically hit that electron, right? And since I only drew 3 atoms, we're gonna let that happen, right? So the photon comes in and hits that electron. It gives that electron its energy. And by giving that electron the energy of the photon, the electron is now free. So it escapes the orbit that it's in. So this guy, I drew that electron really big. But now we have this giant electron with lots of energy, and now it's going to start moving around. Right, so it gets kicked out of its orbit, and now it's free to run around. Now the electron has something very important. The electron has a negative charge, right? So we have this electron with a negative charge and this electron with a negative charge, and just like trying to put 2 north poles of a magnet together, this is going to repel that, right? So this this electron acts on this electron, and now this electron gets kicked out. And now we have 2 electrons running around, running amok, right? And, we'll kick this electron out of its orbit. And so why is that important, right? Well, before, these atoms or these molecules had no charge. And if I was going to boil down all of chemistry into one sentence, all of chemistry is atoms or molecules trying to have a 0 net charge, right? So if I take away these electrons, not only do I have electrons running amok everywhere, but I've left this atom with a net positive charge. So I'm gonna find, yeah, we're gonna get a really angry red and draw a big positive charge on that. Positive, positive, positive. Also, if you remember from your high school chemistry, a charged particle is called an ion. So photons that have enough energy to create ions are ionizing radiation. So now you have atoms or molecules which are not neutrally charged, and they're going to do everything in their power to get no net charge. So the way I like to say this is that now we have all of these atoms that are going to go run around in your body doing chemistry where they are not supposed to be doing chemistry. And that can be very bad for us because as robust as we like to think of ourselves, we are just a delicate balance of chemical reactions and one little, well, not one, but, you know, ion pairs running amok are gonna mess some stuff up. And that is actually how you cause, that is fundamentally how gamma radiation does damage, right? So one of the worst things that can happen is when this process occurs while a cell is dividing. So if you can remember back to like high school biology, right? Cells reproduce by like duplicating their DNA and then splitting in two. But in that moment, when they're splitting in two, the DNA is like exposed. So we could have electrons or these other ions come in and start busting up your DNA, and that can cause mutations, right? And then that can cause lots of other problems. I am not a biologist in any way, shape, or form, but this is my whole understanding of like cancer. Cancer is unregulated cell growth, right? So you just have cells that are going willy-nilly, growing all over the place where they're not supposed to. And normally your DNA has a mechanism to say, stop that right now. But a mutation, right, which can be caused by chemistry running amok, doing chemistry where it's not supposed to, can turn off those checks and balances in your DNA that tells cells to stop it. That is how photons cause biological damage, right? So when we're talking about radiation damage or damage by gamma radiation, this is the process that's happening. It just really sucks when it happens inside of a person. So the premise of Hulk, right, is that he gets exposed to a bunch of gamma radiation, so a bunch of these high energy photons, and this causes his cells to mutate in such a way that he turns green when he's angry, right? Delightful science fiction, lovely character, can't wait to see the Avengers movie. But in reality, exposure to bunches of radiation will cause genetic mutations, just not ones you want, just the ones that are gonna kill you.
Okay, team, that's all I've got for you today. I hope you enjoyed this video. Like and subscribe if you want to see more content. Let me know down in the comments what you thought. If you have any ideas for future videos, any topics you want me to tackle, I'll take them on the best I can. Until next time.